So I'm particularly interested on these couple of problems. I took a snapshots of a couple of your work. I'm particularly interested in the differences between approaches that I'm kind of seeing represented here. So first, I kind of want to look at problem 3. No, not problem 3, problem 4. Problem 4 asked you to divide negative 11/12 divided by 2/3. So what's your strategy when you're dividing two fractions? Keep, change, flip. Again, anytime we're changing one type of arithmetic to another, whether it's multiplication and division or addition and subtraction, keep, change, flip is a way to do it. So we kept the negative 11/12 as it is. We flipped multiplication for division, and then we flipped the 2/3 into its reciprocal 3/2. And then after that, it turns it into a multiplication problem, and when you multiply fractions, you can multiply straight across. Here, negative 11 times 3 is negative 33. 12 times 2, 24. Okay. So negative 33 over 24. But that's not the same answer as we got over here. So what's the difference?
One's simplified.
One is simplified and the other is not. Right. So it's not that these two answers represent different numbers. They represent the same number. And so they are both correct in a mathematical sense. But in a simplicity of expression sense, one of them is slightly simpler than the other because it uses smaller numbers. What's the connection? What's the step that connects this fraction to that one? 3. What do I do with that 3? Divide it. So I'll just take 33 divided by 3, 24 divided by 3, and then we see that these two answers do in fact agree with one another. Okay. So I don't know how WebWork scores it. If you enter in a fraction that's not simplified and WebWork is expecting one that's simplified, I think usually it'll give you a little message that says there may be simpler terms, or this may not be in its lowest terms, or something like that. So again, it doesn't mean that it's wrong, it just means that you've got a little bit, one more step to do. And that's the kind of thing that I take into account when I'm looking over all of your work, as I do, as I will on the quiz that you take on Wednesday. And I just have to make a determination, does this person really know what they're doing when it comes to arithmetic or not? And forgetting to simplify, if it happens once, it's probably not a big deal. If it happens persistently, then I might say, yeah, you should probably go back and review simplification. But that was an interesting difference in approach. There's also another difference in approach between the methods that the two of you use to solve this problem that I'd like to hear a little bit more about. So in your solution, you went straight ahead at it the way that we've been doing today. You did something ourselves a little bit differently. So tell us about how you approached it. What exactly was the step that you did here that turned this 12 into this 4 and turned this 3 into this 1? What were you actually doing there? Dividing by 3. This same dividing by 3 that you did at the end of the process, you did in the middle of the process. Good news is it doesn't matter when you do it. We all end up in the same spot. So we see that happening in your work later on here in number 6 as well, right? Where you were taking this 25 and this 15 and dividing those by 5 to reduce that into a 5 and a 3. Taking this 4 and this 2 and reducing them into a 2 and a 1. Taking this 49 and the 7 and reducing them by 7 into a 7 and a 1. And so by the time all of that dust settles, let me think about this in a slightly different way. I'm gonna write the same work that you did, just arranging my information differently. So the problem was 2 over 25 multiplied by 7 over 4 multiplied by 15 over 49. And you approach this by sort of taking bits and pieces from one denominator and reducing them by bits and pieces of the numerators of other fractions. Here's how I like to see it. Let's go straight ahead at this problem one more time and just multiply everything straight across. But I'm not going to actually carry out that arithmetic. I'm just going to kind of write it 2 times 7 times 15 across the top, and 25 times 4 times 49 on the bottom. So I know that ultimately what I'm doing is I'm multiplying straight across. But here's the thing about multiplication. What's the difference between 7 times 15 on the one hand and 15 times 7 on the other hand? You're shaking your head. What does that mean? There's no, the answer, the product of those two things is the same. That's what we call the commutative property of multiplication. When I multiply, it doesn't matter the order in which I multiply two answers, right? The product remains the same. So what that allows me to do is I can take 7 and take 15 and I can trade places. Right? I can flip-flop where the two of them are. And the net effect that that has is it makes it so that my 15 is above my 5 and my 7 is above my 49. Right? if I do that, then I can kind of take apart these fractions if I want to. And now look, two of my factors are now fractions which I can simplify into smaller terms. Because after all, 15 over 5 can be simplified into 3 over 1. And 7 over 49, 1 over 7.
I think the 5 is supposed to be a 4.
I think you're right.
I'm like, it was going to help.
I'm sorry, yeah, no, I screwed that up. You're right, I very much screwed that up. So please pay attention to the process here and not the details. Of course, I won't cut you that same slack on a quiz, but yeah, so let me pull that back, and we'll do it with the actual numbers. Thank you for catching my error. Again, it's always better if you can correct your own errors, but correcting my errors is even better than that, so thank you. So 15 and 7 trade places. We'll put the 7 here, the 15 there, and actually that doesn't help us much, right? Because that doesn't really give us any fraction that we can make any simpler. So let's try a different swap. What if I swap the 2 and the 15? If I trade places on those, then the 15 goes over the 25, the 2 goes over the 4, and then those fractions can be made simpler, reducing the first one by 5 to give me 3 over 5, and reducing the second one by 2 to give me 1 over 2. And then I think this is still, gosh, what is this? It's 1 over 7. And now I've simplified these fractions in place as simple as they can be, and now when I multiply them straight across, I again get the answer that you got, 3 over 70. Right? So I can do that simplification up front, or going straight ahead, I can just multiply everything straight across first. It's going to give me this really big looking fraction, 210 over 4900. And then I have to do all of my simplification at the end of the process. And so here it was kind of tricky because he had some big numbers, but I can divide everything by 2 to reduce that down. Then divide that result by, was that 5? Yeah, it must be 5. To reduce that down, because after all, the net effect of both of these is we divided by 10. Right? 4,900 became 490, and 210 became 21. And those still had a factor in common of 7 that we divided by to get down to our final answer. So the good news is you can do the simplification at any step along the way. Whatever feels the most comfortable to you is the way to go about it. One of my goals of this course is that you develop a strategy that's going to click for you for these problems. As long as it's a strategy that leads to a correct answer, then that's the one I want you to hang on to. So we saw a couple different ways of approaching these problems. Now a good idea would be to go home and practice.